Hey guys, this is Advent of Code 2020, Day 8, Part 1. Here we go. Day 8, Handheld Halting. Your flight to the major airline hub reaches cruising altitude without incident. While you consider checking the in-flight menu for one of those drinks that comes with a little umbrella, you are interrupted by the kid sitting next to you. Their handheld game console won't turn on. They ask if you can take a look. You narrow the problem down to a strange infinite loop in the boot code, your puzzle input of the device. You should be able to fix it, but first you need to be able to run the code in isolation. The boot code is represented as a text file with one instruction per line of text. Each instruction consists of an operation, ACC, JMP, NOP, and an argument, a signed number like, ACC increases or decreases a single global value called the accumulator by the value given in the argument. For example, ACC plus 7 would increase the accumulator by 7. The accumulator starts at 0. After an ACC instruction, the instruction immediately below is executed. Jumps, the next instructions, the jump instruction to execute found using the argument as an offset from the jump instruction. For example, jump plus 2 would skip the next instruction, jump plus 1 would continue to the next immediately below it, and jump minus 20 would cause the instruction 20 lines to execute. Okay, next. NOP stands for non-operation. It does nothing. The instruction immediately below it is executed next. For example, consider the following program. Okay, let's consider this program. These instructions are visited in order 1, 2, 3, and then jumps forward 4, 5, 6, 7, 8. Okay. First, NOP does nothing, then the accumulators increase from 0 to 1. Jumps 4 near the bottom. After increases the accumulator from 1 to 2, jump to -4 executes, setting the next instructions to the only ACC plus 3. It sets the accumulator 5, and jump -3 causes the program to continue back at the first ACC plus 1. This is an infinite loop. With this sequence of jumps, the program will run forever. The moment the program tries to run an instruction a second time, you know it will never terminate. Immediately before the program would run an instruction a second time, the value in the accumulator is 5. Run your copy of the boot code immediately before an instruction is executed a second time. What value is the accumulator? Okay, so I need to do... Okay, so what I'm going to do is, because I want to check to see if each one was ran twice, what I'll do is I'm just going to create a list of int, and we'll call this used index. So this is where I'm going to store all the indexes that have been used. I'll just check to see if it's been used before. If it has, then I know I'm at the end. For int I equals 0, I is less than input dot count I plus plus. So this is the for loop that I'm going to go through each code. Now I'm going to say var, let's instruction equals input at I, split. I'm going to split it by spaces. That's going to give me NOP in index 0 and then plus 0 in index 1. Now I just need to switch instruction on. So now I'm going to go through each instruction. So in the case that it is NOP, do this, which is nothing. In the case that it is ACC. Do this. We're going to say ACC equals ACC plus. You know what? I didn't create a variable for that yet. AC. Stop doing that. Plus. Converge. Instruction at 1. So we're going to add it to it. It starts at 0, they said, so do that. Break, case, jump equals, so we're going to set I equals I plus, do the same thing right here. Break. So if I equals 1, so if I equals 2, this will add 4, which will bring it to 6. I need to subtract 1 because I'm doing the plus 1 up here already. So what's going to happen is, because it's going to go up here, that should work. So that'll go through the instructions. Now what I want to do is, so it's going to add to the ACC. Now what I want to do is I want to check this used index. So used index, we need to add our indexes that we're using to it. So add I. There we go. Now we're going to have a list of indexes. So I want to check to see if the index is about to be used twice. If it is, I want to break out of it. So I'm going to say if used index contains I, then break. So we're going to exit out, but not before we dump that ACC code. 5. That's what they got, right? What did they get? 5. Okay, so let's get our puzzle. Get rid of that. I need this. C. This here. C. Let's run this. 1782. Got it. Okay, so that was the end of day 8, part 1. Thanks, guys.